please title your page Simplifying Radicals Review. Make sure you include your page number. And what I want you to do right now is I want you to turn back to Unit 3. On my notebook it was page 35, and I want you to review the birthday cake method. Look at the examples that we did. So if we were to do the birthday cake on 360, down here at the bottom layer we write 360, and we want to start with the smallest prime that goes into 360, and so we're going to start with 2, and so we're going to do 360 divided by 2. 360 divided by 2 gives us 180, so the 180 goes on top, and then we just keep repeating. We're going to do 2 again. We keep using 2 until we can no longer use it. And so 2 goes into 80, 180, 90 times. Okay, 2 can go into 90, 45 times. Now here, 2 can no longer go in. So when 2 doesn't go in, the next smallest prime to try is 3. 3 can go in 15 times. Again, try 3 again. 3 can go into 15 5 times. Now 3 can't go into 5, and so we try the next smallest prime, which is going to be 5. And our goal is to stop when we get to 1, because that's the candle on our cake. Alright, so now if we were to write this, the prime factorization of 360, that would be 2 times 2 times 2, 3 times 3 times 5. Now one easy way to check to see if that is right is just take a calculator and go 2 times 2 times 2 times 3 times 3 times 5, and that should equal 360. So that's our review of the birthday cake. So on the next page we have simplifying radicals, and so I want you to quickly review the steps for simplifying radicals. So now we're going to simplify the square root of 27 x to the 4th, and the first thing we want to identify is the index, and so when there's no number written on the outside, it's a square root, so the index is 2. And so start by doing the birthday cake of 27. So the birthday cake gives me 3 times 3 times 3, and so I'm going to rewrite that underneath the radical symbol, and so 3 times 3 times 3, and then the x to the 4th I'm going to write in expanded notation, so I'm going to write out x 4 times. And the reason we do this is because the index, that 2 on the outside, tells us how many we need to group together. So every group of 2 I circle. So I can't circle another 3 because there's only one of them, but I have these 2 x's I can circle. I can have these 2 x's I can circle. And so every time we circle something, we write it on the outside. So I have the 3 on the outside. I have this x on the outside. And so I circled 2 sets of x's, so I have 2 x's on the outside. And now we just rewrite it with what's remaining on the inside. So anything that's not circled remains on the inside, and so that's a 3. And now we clean up or simplify the outside, and so that would give us 3x squared rad 3. And since this is a square, we don't need to write the 2 there. So the square root of 27x to the 4th simplifies to 3x squared rad 3. So now we're going to look at the 4th root of 567 n to the 9th. So just like before, we're going to start with our birthday cake. So off to the side I'm going to write 567. And Since this is an odd number, 2 won't go into it, so we're going to start with 3. And 567 divided by 3 is 189. And then we try 3 again. Now I happen to know that 3 goes into this because if you take 5 plus 6 plus 7, you get 18. So if the sum of the digits is divisible by 3, and 18 is divisible by 3, that means 3 goes into it. So as I look at 189 and I want to see, do I want to try 3 again, I do the same thing. 1 plus 8 plus 9, that also gives me 18 again, and so 18 is divisible by 3, so that means 3 does go into it. And so this idea of this birthday cake is like doing division. How many times does 3 go into 18? 6. How many times does 3 go into 9? 3. So again, 3 is going to be able to go into 63 because if I add up the digits, 6 plus 3, that equals 9, and 9 is divisible by 3, so that means that 3 will go into 63. So 3 goes into 6 twice, 3 goes into 3 once. Now obviously, 3 goes into 21, but I'll just show you one more time. If I add up the digits, 2 plus 1 equals 3, and 3 is divisible by 3. And 3 goes into 21 7 times. Okay, 3 doesn't go in, 4, 5, 6, 7, so our next smallest prime is 7. And 7 goes into 7 one time, so 1's our candle on top of the cake. So now your first step after doing the birthday cake is to expand it out. So I'm going to come over here and write 3 times 3, 4 times. And again, you could check this on your calculator by going 3 times 3 times 3 times 3 times 7 just to make sure that it does equal to 567. So all this is going to be under our radical symbol with the 4th root. Now the n to the 9th, I'm going to expand. So I have 9 underneath the symbol. Let's put this in a different color. Alright, so I want groups of 4 now. So every time I circle a group of 4, I'm going to write it on the outside. So I get to write a 3. And I'll use different colors for each one. A group of 4 goes on the outside. A group of 4 goes on the outside. Now there's no other groups of 4, so now I rewrite it with the remaining on the inside. So there's a 7 remaining, and there's this n remaining. And then now, don't forget, this, if it's blank, means 2, so we have to put the 4 every time. And now we clean up the outside. That would become 3n squared, the 4th root of 7n.